Assalamu alaikum. Today we're going to talk about the real function, and we used to imagine the real function as a machine. This machine takes in a real number and produce another real number, and since the input and the output are real numbers, that's why we call it a real function. The most common names for the functions are the letters F or G or H. You can use any other alphabet letters. The entries for the function, the input for the function are called the domain of the function, and the output are called the range of the function. How the machine changes the input into a certain output is given by what we call the rule of the function. So say I have a function defined by f of x equal x plus 1. This is like the manual of this machine. It describes how this machine works. So if you put in a real number like 2, what do we expect the output? The output will be determined by this rule here. This says whatever comes in is gonna come out the same number but plus 1. So if you wanna put 2 in here, you're gonna follow this rule. If 2, here's 2 inside the machine right now, equal 2 plus 1, which is 3. So you put in 2, you get out 3. You put 4, you get out 5. You put 6, you get 7, and so on. After this, we talked about two main categories of the function, the polynomial and the non-polynomial. The polynomial function is the most important type of functions. I'm not saying the others are not important, but these are the most common use functions. Even you will learn later on how to change the non-polynomial into a polynomial, and this is not our focus in this year. So how to determine if the function either polynomial or non-polynomial? This by looking at the rule of the function. If the rule of the function, the power of the variable is a positive integer number or 0, or say it's a natural number. Again, if the power of the variable in the rule of the function is natural number, then this function is a polynomial. Like these examples here. If x equal x plus 1, this is a polynomial. Why? Because the power here is 1, it's a natural number. The power of x here, there is no x. You can say it's x power 0. Still, the power is natural number. So this is a polynomial. If x equals 3x squared minus 5x plus 2, this is also a polynomial. Why? Because the power of the variable x is still, here's 2, that's a natural number. Here's 1, that's a natural number. Here's 2, which we call it absolute value. You can say it's 2x power 0. Still the power is a natural number. So this is a polynomial function. G of x equal 5. This is also a polynomial function because you can say it's 5x power 0, and 0, the power of x, is still natural number. So this is natural numbers, natural powers. So these are polynomial functions. On the other side, these are examples for non-polynomial function. If I say if x equal x plus 1 over x minus 3, this is not a polynomial function because there is x in the denominator. So this is not a polynomial function. If x equals square root of x plus 5, this is not a polynomial function because x is under the root, the square root. Of x equal x power 2/3 plus 1. This is not a polynomial function because the power here is not a natural number. The power here is not natural number. The power here is not natural number. So, in short, by looking at the rule of the function, if you find x in the denominator, or x under the root, or x as a base for non-natural number, then this shows us that the function is not a polynomial function. Now, how do we determine the domain of the function from the rule? Here is a definition. The domain of the function is the set of all the real values that make the value of the function are real values as well. Example, let's say example number 1. Find the domain of f of x equal square root of say x plus 2. Solution. From the definition of the domain, you are looking for the values that goes in the function and produce a real values as a result. Since this is square root and you need this square root, you need the value real. And you know, if the value under the root is negative, square root of negative any number doesn't belong to R. So you need the value underneath, under the root, must be positive or 0. And that's how we will determine the domain. We say square root of x plus 2 is defined, or say belongs to R. Either one is correct. You say square root of x plus 2 belongs to R, or you say square root of x plus 2 is defined when x plus 2 is greater than or equal 0. And this is a very simple first degree inequality. Solution for it is x is greater than or equal negative 2. Write down this as interval. So x belongs to negative 2 closed at infinity. This is the domain of the function of x equals square root of x plus 2. Example number 2. Determine the domain of g of x equal x plus 3 over x minus 5. And again, I'll remind you, we are looking for the values that goes into this machine or this function, and the result must be a real value. So you're looking for which value you put in here makes it not real, so you can put it away. Since this is a rational function, fraction, so the fraction must not equal 0, because if the domain if the denominator equals 0, the whole value will not be real. So the domain is the whole real number except 5. Why 5? Because if you put 5 in, it's gonna come out in the denominator 5 minus 5, which is 0. On top it's gonna be 8, no problem with that. 8 over 0, that's undefined. That's why we have to exclude 5 of the real number set. So the domain for this function, the domain is R except 5. Example 3. H of x, find the domain of the function h of x equal, now square root, say x plus 3 over x minus 2. Solution. Here we have to look at the numerator and the denominator. The denominator, which is x minus 2, cannot be 0. It means that x cannot be 2. Because if x equal 2, the denominator will be 0, and then the whole value would be undefined value. So I know now that 2 is out of my domain, can't be in the domain. By looking on the top, I know that x plus 3 must be greater than or equal 0. And this is first degree inequality. Its solution says that x must be greater than or equal negative 3. These together determined the domain of the function. X has to be greater than or equal negative 3, but not 2. So the solution, the domain, is x greater than or equal negative 3. I'm going to write it down as interval, so it's going to be negative 3 closed and infinity open. Exclude from that, take away from that, the number 2. This is the domain of the function. Note number 1, the domain of a polynomial function is the entire real numbers set. Number 2, the domain of the root function, if it's a square root or fourth root or sixth root or eighth root, if the index of the root is even, then whatever under the root must be greater than or equal 0. So the domain is x plus 1 greater than or equal 0. Whatever in here it has. If it's x plus 1, x plus 4, x plus 5. Number 3, if the function is a rational function in form of numerator and denominator, say here x plus 5, here x minus 2, then the domain is R except the zeros of the denominator. Zeros of denominator. If you guys forgot the term zeros of the denominator, I remind you the zeros are the values that make the denominator 0. What value make this denominator equal 0? It's 2. Where I come from with this, just take x minus 2 equals 0 and solve this simple equation. So x equal 2 is a 0 of the denominator. Thank you for now, and I'll see you in another video. Assalamu alaikum.